Graphing and solving quadratic inequalities. It's really similar to graphing and solving linear inequalities, so this is pretty fun. So you just go through, follow these 3 steps, and you're in good shape. So the goal is to understand how to graph and solve a quadratic inequality. And remember, with inequalities, they look like these: less than, greater than, less than or equal to, greater than or equal to. And so you're going to have to figure out if it's going to be a dotted line or a solid line, and then shading, if that brings back some memories. Alright, so graph quadratic inequalities. You can graph quadratic inequalities in 2 variables using the same techniques you use to graph linear inequalities. So step number 1, decide if you've got to use a solid line or a dashed line. And the key is right here. If it's inclusive, if it's got the equal to underneath, if it's less than or equal to, greater than or equal to, then it's going to be solid. If not, it's going to be dotted. Step number 2, just test a point. Let's cross off this inside the parabola. You can test a point anywhere. So you choose a point of your choice. Our number 1 point is going to be the origin, 0, 0. Because zeros are super easy to work with. And step number 3, if the point you chose gives you a true statement, then you shade the region it lies in. If it gives you a false statement, you shade outside. So let's do an example. Okay, y is less than or equal to x squared minus 6x plus 10. This guy is going to be a dotted line. Okay, now just graphing our quadratic. As soon as I recognize it's a quadratic, there's an exponent of 2, it's going to look like a parabola. So it's going to be curved, and what's sweet about a parabola is there's always an axis of symmetry. They're totally symmetrical. So if I can find the axis of symmetry, that's going to be move number 1. Move number 2, find the vertex. The vertex is either it's right on the axis of symmetry. It's either the maximum, it's the highest point, or it's the lowest point. So it'll be like right here, right on the dead center. Alright, so find the vertex. Axis of symmetry is negative b divided by 2a. So we're going to have to look at our coefficients and determine what is our a, what's b, what's c. In standard form, a is going to be 1, b is a negative 6, and c is 10. So I'm just getting them from what's in front of the x squared, what's in front of the x, what's in the constant, the number all by itself with nothing, no variables. So that's where a, b, and c come from. Now I just need b and a, so I plug them in. So it's going to be a negative b, so it's a negative negative 6, that's a positive 6, divided by 2 times 1. So 6 divided by 2. My axis of symmetry is right here. It's x equals 3. So on my x-axis at 3, I'm going to have a vertical line. Okay, my vertex I know is going to land right on that line. The vertex, slick way to find the vertex is just make a table. Make an xy table. I know the x is going to be 3 since it lands on that line, and then to find the y you just plug it in. I'm going to plug in a 3 there for that x, I'm going to plug in a 3 there. So the formula says to do x squared, so it's going to be 3 times itself, that's going to be 9, minus 6 times 3, 9 minus 18 is a negative 9, plus 10 is 1. So if I go over 3 and up 1, I'm going to put a dot. Okay, now I'm going to choose another point. I'm going to choose 2. I'm going to stay kind of close to my axis of symmetry. So 1 to the left is 2, 1 to the right is 4, and I'm going to choose 2 to plug in because 2 is a little bit easier for me. So 2 squared, that's 4. 6 times 2 is 12. 4 minus 12 is a negative 8. Plus 10 is a positive 2. So I'm going to go over 2, up 2, and then this point reflects across the axis of symmetry. So I get a point for free. And the next point, I'm going to go ahead and choose 1. So 1, plug it in here, 1 squared, that's 1, minus 6 times 1, So that's a negative 5 plus 10 is a positive 5. So if I go over 1 up 5, it reflects itself right there. So my parabola looks like this. Okay, now let's plot a point. Let's choose a point. Let's go for the origin right here. 0, 0. So x is 0, y is 0. So here's what I'm going to do. I am going to replace both those variables. I'm going to replace, let's see, that's 0, 0. That's a x, that's a y. So I'm going to make y 0. 0 is less than or equal to 0 minus 0 plus 10. So here's my statement. 0 is less than 10. True or false? True. So I know the answer is going to be in the region where my origin is. So it's going to be kind of everything outside of the parabola. So I'm going to shade this region right here. Let's do one more. Okay, y is greater than or equal to x squared plus 4x plus 7. So maybe move number 1. Let's find our a, b, and c. A is 1, b is 4, c is 7. So now my axis of symmetry is going to be negative b divided by 2a. So it's going to be a negative 4 divided by 2 times 1. It's going to be x equals a negative 2. So come down here on the x-axis right here. Oh, you know what I just thought of? The first one I think we messed up. Alright, I'm sorry. Let's go back to this first one. I think the first one looks pretty good except for I just remembered. It's got to be a dotted line. So I'm going to have to go back and erase. Got a little carried away. Alright. Now it should be good. So the second one, okay, this one's going to be a solid line. Because of the equal to right here, it's going to be a solid line. So, let me find the vertex. Let's make a table, x, y. I know the x has to be negative 2. So let's plug in the negative 2. Negative 2 squared is a negative 2 times negative 2, that's positive 4. Negative 2 times 4 is a negative 8, so positive 4 to negative 8 is a negative 4 plus 7 is 3. So over 2, up 3, left 2, up 3, there's my vertex. Okay, I'm going to try, I'm going to plug in a negative 1. Negative 1 squared is 1. 4 times a negative 1 is a negative 4. 1 plus a negative 4 is a negative 3. Plus 7 is 4, so left 1, up 4. Reflects right there. And I'm going to try 0. 0 gives me 7. So 0 up 7, and it reflects right there. Dotted line, or not dotted line, this one should be a solid line. Alright, now let's check our origin. Let's check right here. 0, 0. So let's make 0 greater than or equal to 0 plus 0 plus 7. So my statement's this. 0 is greater than or equal to 7. Is that true or false? That's false. So the region must be inside the parabola. So if your parabola does go through the origin, for example, if you're looking at something like this and your parabola goes through 0, 0, then you're going to have to choose another point. You're going to have to still choose something 0. I'd choose this guy right here. Over 1, 0. So if it's going through 0, 0, you're going to have to choose another point.